Assalamu alaikum, welcome to my channel Physics with Hasnain. Today we are going to discuss difference between micro and macro state of the system. These are most widely used terms in statistical mechanics. In order to discuss their difference, we have to consider what is a system and what is meant by a state. A system is a set of component processes or variables and that interact with each other to produce a collective specific outcome. What this means is that, for example, we have a box and three particles in it. Each particle is moving with a certain velocity, say v1, v2 and v3. This is a system because a box and three particles are under our considerations. Here, set of components mean set of particles. Each particle is a component of our system, and variable associated with our particles or components is velocities. It can be velocity, it can be energy, but here I chose velocity. And these particles interact with each other by colliding and transferring their energy and exchanging their velocities and speeds, and to produce a collective specific outcome. There are many kinds of specific outcomes they can have. For example, their pressure is a collective outcomes of their random motion, their temperature, their total kinetic, their total internal energy. These all are their collective outcomes, and each particle is contributing to these terms, let's say temperature and pressure and internal energy. Temperature, pressure and kinetic energy and internal energy all are macro properties, and while velocity is a micro property of a system, as clearly from the meaning that micro means on small scale and macro is a scale bigger than micro scale. Micro properties of a system can have on very small scale. uh, Here particle 1 have velocity v1 and particle have velocity v2 and particle have velocity v3. So on very deep level and small scale, we have information about each and every component of our system. So velocities are property of a system at micro level, and temperature and pressure are properties of the system at macro scale. Next, we consider what is meant by a state. A state can be defined as a possible situation, condition, or nature of a system. What this means is that, for example, we have at any instant of time t1, say t1, we have velocity v1 is equal to 3, v2 5 and v3 is 7. These particles are in random motion. They can exchange their velocities, uh, but at any instant of time we have chosen velocity v1 as 3, v2 5 and 7 for v3. So at time t1 we have v1 as 3, v2 5 and v3 7. So this set of velocity is a state of the system because at any instant of time this represents uh, a possible condition or situation of a system. The word condition which this is telling is that particle 1 has velocity 3 and particle 2 has velocity 5 and particle 3 has velocity v3. So this is the situation of our system. At later time t2, this situation of a system can be changed from the previous one because these particles are in random motion, and let's suppose particle 1 has collided with particle v3 and they have exchanged their velocities. So uh, after certain time at time t2, particle have velocity 7 because it has been changed by collision from particle v1 and v3. Particle velocity 5 is fixed because it is not colliding with other particles, and particle v3 has velocity now 3. So this is another possible situation or condition of a system. At time t1, situation of the system was velocity 1 3, velocity 2 5, velocity 3 7. After certain time at time t2, condition or situation of the system was velocity v1 7, velocity v2 5, velocity v3 3. So these two are possible situations of the system, or more generally we can say these are two states of the systems, and these are microstates of the system. How these are microstates of the system? Because they tell about micro properties of the system. As I said, velocities are micro properties, so these states are telling about micro properties of each and every particle of a system. While macrostates are while a macrostate is a set of many microstates that are similar in nature, but to explain this point, uh, first consider another example. Here again we have chosen 3 particles in a box, but there is a restriction that uh, any particle can only choose velocity either 0 or 1. There is no way around that a particle can choose velocity 2, 3, 5, 6. No, they can only choose from 0 or 1. There is a restriction on their velocities. So the possible states of the systems are 0, 0, 0, 1. Here this is a particle 1, this is a particle 2, this is a particle 3. Possible states are that all particles have velocity 0, 0, 0. Particle 1 have velocity 0, particle have velocity 0, but particle 3 has velocity 1. So there are all combination, all all possible states are microstates of the system that a system can have. These are 8 in number: 1, 2, 3, 4, 5, 6, 7 and 8. How these are 8? Because there are only two velocities, either 0 and 1, and there are 3 particles, so 2 raised to power 3 is 8. There are 2 possible velocities and there are 3 particles, and so total number of states are 8. These states are microstates: 0, 0, 0, 0, 0, 1, and these are two microstates: 0, 1, 0. This is another microstate. 0, 1, 1. This is another microstate. I want to here share that a useful information that all microstates are equally probable, and probability of probability of occurring one microstate is 1 divided by total number of microstates. Here n is 8. Total number of microstates are 8. So probability of each microstate is 1 divided by total number of states, here 8. So we say that probability, what this means is that probability of occurring occurring state that particle 1 has velocity 0, particle 2 has velocity 0, and particle 3 also has velocity 0. This is a possible state. So this state has the probability of occurring is 1 by 8. Similarly, particle 1 has velocity 1 and 2 and 3 has velocity 0. This is another possible state that the system can have, and probability of this state is also 1 by 8. This is more probable, this is more probable, and this is less probable. Number of microstates it contains is larger than the probability of a certain microstate. Here something is wrong. It should not be inversely but proportional to the number of microstates. So this is wrong here, because probability of a certain macrostate is not inversely but it is proportional to number of microstates. In this way